Hello, welcome to our fifth video on differentiation, and today we're going to be covering particle motion. So, right now we're going to find out when particle P is moving to the left. And for the AP Calculus AB exam, things move to the left when their velocity is negative. So, particle P, what do we know about particle P? We know the position. And take note of this interval. Always, I usually like box this interval because if you forget it, it can cause some problems for you. So the position at time t is given by x pt equals ln of that mess. And we've got to find the velocity. So I'm going to draw a little thing here. So we're going to have position, and then if you differentiate, you get velocity, and then if you differentiate again, you get acceleration. And you can also go the other way with integration, but we'll cover that in future videos. So when is particle P moving to the left? So first we're at position right here, so we've got to go to velocity, so we're going to differentiate. Right, so you're going to use chain rule here. So first we're finding the derivative of this function evaluated at that function. So that's going to be, the derivative of ln is 1 over something, and the something is that, plus 10. Okay, and then we're multiplying by the derivative of this with respect to t, so it's going to be 2t minus 2. And then we're going to get a 2, and factor out that 2 there. T squared minus 2t plus 10. Okay, so we're going to find out when this is negative. Alright, so we're going to make a sign chart now. So sign chart will tell us where the sign of a function over a given interval. But in order to make that, first we need to find the zeros of this function, or where it doesn't exist. So right here, let's start with the numerator, right? So either the numerator or the denominator should be 0. So if this is 0, right, then t is 1. Alright, pretty easy. Now what about the denominator? Maybe the denominator is 0 somewhere, and then technically we would need to consider that a critical point as well. Well, this can't be factored easily, so let's just solve this using the quadratic formula, right? So here are our a, b, and c values. So x is minus b plus minus the square root of b squared minus 4ac all over 2 times 1, or 2. So I'm going to stop right here. Well, maybe I'll just do one more, because you'll get 4 minus a 40 over 2. Now this discriminant is imaginary, right? Because you get square root of minus 36, and that is not a real number. So right away you know that this equation has no real solutions, so the denominator is never 0. So, okay, great. So now we just have to account for t equals 1 as our critical point. So, let's make the sign chart now. Always label your sign chart with the function that you're doing, and always put the interval that you're going across, so from 0 to 8, right? And then t equals 1, put 0 right here. So this indicates that, xp prime t was 0 at t equals 1. So now we just got to test some points. So xp prime, let's try 1/2. I mean, we can also try 0 because we don't actually know what it is at 0. So 2 times 0 minus 1 over 0 minus a 0 plus 10. Okay, so pretty obviously that's going to be less than 0. So we put a minus sign right there, and we continue on testing points. So maybe I'll try it at 8 this time. 2 times 8 minus 1 over 8 squared minus 2 times 8 plus 10. Okay, that's a 2 times 7. That's kind of annoying. 64 minus 16 plus 10. I probably should have chosen a smaller number. But I'm going to have faith that it's going to be greater than 0. I'm too lazy, not going to calculate the value of this. And so we know that this is going to be, in fact, greater than 0, right? So we put a little plus right there. Okay, so now remember the question was, when is it negative? So it's asking for this interval. And keep in mind, you can test values at these points that you marked, so long as it's not 0. If it's 0, then you might want to just test a point in between. But in this case, right, we know that t will be in the interval, the closed half-open interval from 0 to 1, or if you're not familiar with this notation, 0 is less than or equal to t is less than 1, right? So in this interval, t is negative because xp prime t is less than 0. Okay, great. That was pretty straightforward. This next part is somewhat straightforward too. So we've got to find all times t during which the two particles travel in the same direction. Okay, so let's do part B over here. Little line here. Okay. So we already have a sign chart for the direction of x, of particle p, I mean. So that's good. But now we need to know what particle q is doing. But we know the velocity of particle q. So vqt equals t squared minus at plus 15. And this factors out nicely, luckily, right? So t minus 3, t minus 5. Okay, so now we're just going to make a sign chart for vq of t, and then we're going to compare it with the sign chart for this one, for p, and then we're just going to, see where they are traveling the same direction. So t is 3 or 5. Okay. Again, label your interval, make your points reasonably accurate, right? Okay. So let's just try some stuff. Oh, right, and put your zeros here. So let's try BQ of 0. It's going to be pretty easy, just positive 15, greater than 0. So put a plus here. Okay, and we're not going to try 3 or 5. We've got to try somewhere in between. Let's try a 4. So 4 squared is 18 minus 8 times 4 plus 15. Okay, so 16 minus 32 plus 15. Oh, man. So minus 16 plus 15. All right. So great. That's barely less than 0. And then our final point, we'll maybe try 8. All right, let's try 6 because it's smaller. Learned my lesson last time. So 6 squared minus 8 times 6 plus 15. Okay. And just doing the evaluation here. 48. Okay, that is taking me a long time, but alas, we've arrived. So, okay, great. So now we have this sign chart for VQ of t. Now we've just got to overlay it. So let me move all this work. Take all this work and just move it to the side, so that we'll get room for our other sign chart, which is xp prime. So something important when you're overlaying sign charts for comparison is you've got to make sure that your all your points are like in sync. So like your 0 and 8 should be aligned with each other, just for clarity. And then when you place down other points in the middle, right, like a 1, like they should make sense relative to this one. So 1 is less than 3, so it should be closer to 0 than where 3 is right now. So maybe it should be right here. Again, you don't have to go super overkill with the accuracy, but only the relative placement really matters. So again, let's fill in our information. So we have 0 right there, negative, and then positive. Okay, so now we just compare. So from 0 to 1, where the particle Q is traveling to the right, but particle P is traveling to the left. But over here, from the the open interval from 1 to 3, Q is traveling to the right, and P is traveling to the right. And then from 3 to 5, same problem, they're not traveling the same direction. and finally 5 to 8. And we are including 8 because it's not 0. So yeah, that's basically where t has to be in order to for the particles to travel the same direction. If this notation is not familiar to you, I'll write it out. So t is in 1, 3, and this interval, right? Where the particles are traveling the same direction. I'm not going to write it out. Okay, so great. We're done with part B. Now, finally, part C. Find the acceleration. Is the speed of particle Q increasing, decreasing, or neither? So you've got to pay very special attention to the word speed and not mistake that for velocity because they are two different things. And we've got to find the acceleration of particle Q at time t equals 2. Okay, so let me copy down VQ of t again. So let's take this here, copy it, drag it, over here. Okay, so now we've got to find the acceleration. Now, where is the acceleration of particle Q at time t equals 2? Well, if we look at a little drawing over here, we've got to differentiate velocity to get acceleration. So let's differentiate this. 2t minus 8, okay. That is the acceleration of our particle at time t. And now we've got to find the acceleration at time t equals 2. So vq prime of 2 is 2 times 2 minus 8. Alright, and we get a minus 4. Alright, now, is the speed of particle q increasing, decreasing, or neither? So what does it mean when the acceleration is negative? It means that its velocity is decreasing. There is a difference. So if we draw this coordinate axis, like if you draw what our acceleration is, it's sort of like, you can imagine it as like a force. So maybe your particle is right here, and there's just a force pushing it to the left, right? Because it's negative. So this is minus 4. But then, right, well, there's a force pushing this particle to the left, but, maybe this particle wants to move to the left, right? Maybe this particle is moving to the left, and a force is pushing it to the left. So in other words, its velocity is negative, and its acceleration is also negative. And in that case, it would start speeding up, right? It's sort of like you're pushing yourself to the left, and then somebody's also pushing you to the left. But then if maybe this particle wanted to go to the right, but this force is pushing it to the left, right? Now it's slowing down, right? So basically, when you summarize all this, if vq of t and v prime q of t have different signs, right, then that means that the particle is slowing down. It's sort of like, you can imagine you're pushing like yourself like on a skateboard or something in one direction, but then somebody's pushing you in the other direction, right? You're going to slow down. But if they are the same, so they're the same sign, then that means we're speeding up. Okay, so let's apply this concept here. So we have the acceleration, but now we've got to find the velocity. So let's find the VQ of 2. So 4 minus 16 plus 15. Alright. And now we can see that clearly they have different signs, so we're going to be following this path, right? So the particle is slowing down because the velocity, right, this is the velocity, and the acceleration have different signs. of course at time t equals 2. So yeah. Okay, that was it for this problem. This is a pretty straightforward problem, but a very, very common type of problem on the AP exam. You'll also see this a lot on the multiple choice section, so I wanted to go over it because it's a very standard type of problem. And in case you were wondering, there is a part D. That's why we haven't used this piece of information, which you will need for part D. We may cover that in a future video when we cover integration. So yeah, that'll be all for this video, and I'll see you guys in the next one.